Hello, myself Saroj Anand Tripathi. Today I'm going to talk about my project in DSA, that is data structure and algorithms. I designed a model based on medicine prediction, which will predict the basis of how many years the medicine will expire, what is the curing time, and what is the maximum cost between at max I have between three medicines. I have considered three medicines at the most. So you can go again means and decide how many medicines and how many parameters you need to give to include more and more medicines and more parameters to give an accurate reading. So now let's see the code. So when this code, so as every line is commented, you can easily understand the code from very beginning. So for include studio standard io.h, this is for defining the library. This is for the maximum which can be changed according variable function can be changed according to the function. So now let me talk about my medicine prediction. So there are many ways to do this. I have used backtracking, the basic method of doing this. So let me tell me how I proceeded with the model. So let's consider three medicine, be it M1, M2, M3, with certain cost, expiration time, and curing duration. And also, none of the medicine can be given if the preceding medicine is prescribed, and consider the maximum time taken by the medicine if more than one medicine is prescribed. So now let's talk about backtracking. What is actually backtracking means? Backtracking is used to find all solutions to the computational problems using constraint satisfaction problems, which allow to incrementally build candidates for the solutions but also abandon candidate as soon as it finds that the candidate cannot be utilized to provide a valid solution. This brute force approach prevents it from optimizing the problem. It gets all the possible solution to the problem. The choice the best suited can be used to get the best possible solution where the problem is expressed as state space tree to form a tree with branch with all possible solution. Now let's talk about the algorithm. So in the algorithm we first consider a queue. So assign the variables in the queue and expand the node in the sequence with the first node of the queue to be expanded first on the basis of first in first out FIFO. Assign the sublist to every memory allocated to each variable and again to those assigned sublist memory continue till all the variables are considered in the branch. Apply condition to each sublist if the parameters are fulfilled, assigned as true, otherwise false. Compare all the assigned true false in the number and possibility to fulfill all the demands. The branch with the least false fulfilling all the demands is considered as solution. Implementing backtracking through the depth of search approach. We consider a starting root node with some number of branches. So now let me talk about the rules for going through this method. So select an unvisited node X, visit it and treat it as current node. Find an unvisited neighbor of the current node, visit it and make it new current node. If the current node has no unvisited neighbors, backtrack to its parent and make that parent as the new current node. Repeat the above steps until no more nodes can be visited. If there are still unvisited nodes, start from the beginning. So now let's see the results. We consider a starting root node with same number of branches as the number of medicines. which have further branches to other medicines till the last medicine arrives. The last medicine arrives in the branch as its leaf. When according to the given consideration we have to cancel the node 12, 13, 8, 14, 9, 10, 15 and 16. This is clearly explained in the research paper I have given. Now considering the parameters we are left, the nodes are in the figure as shown in the research paper. Now let's see about the time. For node 4, the expiration date is more than the time taken for curing. For other nodes, the time taken for cure completes before the expiration date. Penalties. On the manufacture of M1 node 2, the penalty would be 0. When continued to node 5, till penalty would be 0. Cause the production cost used is completely similar for node 8. Going back to node 6, we notice a penalty of rupees 10. Going for node 3, we face a penalty of rupees 5. Now let's discuss about the cost for patient. The cost is going to leaf node 8 would be rupees 21, while going for node 6 would be rupees 11, till node 7 would be rupees 16. After judging the penalties, cost and time parameters, we cancel leaf node 4 of time parameter, leaf node 8 because the cost affordability, and leaf node 6 due to penalty cost for production. Thus the final degree tree after going through all the solution and parameter satisfaction would be 137. Thus we can say that the best prescription would be branch to node 7 with cost 16 with penalty of rupees 5. These CAN methods in the research paper I have done it with two more methods, that is branch and bound and least cost upper bound. So these two methods are clearly explained in the research paper. Now I'll go on to explaining my code. So now let us define some structure medicine for creating a queue for, so that it would be easy for me to not again declare the structures characters or the elements of the queue's characters, the structurizations. So now let's see, in the type struct medicine, character ID is given 5, expiry is an integer, cost is an integer, duration is an integer. Void disease medicine med. This is the basic creation for medicine function. I've declared it here, but I have, so I would be easily able to show my function here. Just a minute. Yeah, disease medicine med, and this is my declaration, the function that I have created for disease medicine prediction, and this is the declaration of the function. This is the min value function for creating the minimum value so that the backtracking model follows the low cost path. As you can see, the function is used to define the minimum value to find the minimum of x. So a simple condition is given: if x is less than y, return x, return y. Int. Now let's come to the main function. This is the main function. So in the main function, I have again declared int ij. This is basically major for the loop that I will be creating. Medicines with expiry time and cost. So as we in research paper I have already discussed that we are considering 3 medicines. So I have created a medicine med for of maximum 4 cells. So you can add even, means you can change this number and add even more priorities and more parameters, and again predict n number of parameters: expiration date, curing date, patent date, anything else you can predict using this. Then this is the medicine temperature. For temporary, this is for the number of medicines. Int n3 is the number of medicines. Sort the medicines cost wise in descending order. So for sorting I have used bubble sort. So this is temperature med j plus 1 med. So this is basic bubble sort. Now I'm printing the result. Means this is the printing of the data that is being given. Then again, for implementing my method for medicine prediction parameters, I have given this med ID, med expiry, med cost, and duration. So all the materials can be included in and given the result. Now I have called the function that is my disease medicine, which I will going to explain now here. Now let's talk about the major function that is doing the backtracking process. This is the void disease medicine, the medicine med, and int. Now let's talk. So I again declare the maximum cost. To create free time slots, I have used this max, which I have previously declared as 100. You can change it according to you. Now I have created fill time slots and also created a variable called find maximum deadline value. So now if this is the loop, so if med expiry is greater than deadline value, then deadline value is the medicine's expiry. So the free time slots initially set to -1, since -1 denotes empty as it's a queue. For now this is the again loop to create the time slots. This is for the creation of the time slots. So this is the this result will give me the maximum time the medicine can go without expiry. Now let's talk about the min value function. The min value function, as I have already discussed here, shows what does it do. It returns the minimum value. So as I have already told you, it follows the low cost method, low cost path. Backtracking follows the low cost path, and its brute force method gives us the best result. So this is the mean value. So I have assigned it to a variable k, the mean value for d max. So it contains 2, that is med I minus 1 expiry, since there are many 2 more remaining medicines, and the other is the deadline value. So I'll run a while loop to check the time that the time slots are created, the free time slots are created. I'll check it if it's empty or not. If it's empty, then time slots will be created and fill time slots will be added. Then it will break. Full time slots are added, then it will be the code, the loop will be broken, and then k minus 1 will be given. K minus minus will decrease the value of the k value, and the loop still goes on. Now this is if that all time slots are filled. If all the time slots are filled, then the function will break, and for the required medicine, to print the reaches the required medicine, I have used the loop called I is equal to 1, I is equal to d max, I plus plus. So this will print the maximum time the medicine is present. The this is not the maximum time. It will give the medicine ID that is the medicine that will be used for the that is the medicine being predicted that is best suited for us. So if I is less than the dmax method, that is the dmax deadline value, then it will return this print. So as you will see in the output, which I'll show you after explaining. So for predicting the maximum cost, I've used this function for max cost. I've initialized as 0. So as the time increases, so it will follow all the nodes as I have explained in the backtracking process. So when it follows all the nodes, it will find the best max cost and it will substitute its value to the max cost here, which means add it. So print f n max cost dn the max cost. So it will print the max cost. Now let me show you the output. Just be patient for 2 to 3 minutes. As you can see, medicine expiry cost duration. So the medicine is M2, M3, M1. As I have entered A here. So it has been sorted according to the expiry date. See, or you can also sort it during the cost duration also. So for M2 the expiry is 2, for cost is 10, duration is 3, M3 is 162, M1 is 151. So as you can see, the medicine can last up to maximum of 2 years. As you can see, this is the maximum expiry date. So if two medicines are considered M3 and M2 as as my result predicts M3 and M2. So for M3 and M2, the maximum they can last up to 2 years, and the maximum cost for both of them is 16. So this completes my program. You can include more parameters and have more predictions. So means just take about the patent duration, uh, the curing time, and also how will the medicine, the number of times the medicine gets changed, or how the time the medicine takes to update itself, or new medicines come into force, replace the old medicine, or how much stronger the previous medicine was from this. You can predict as much values as you can.